will start with the assignment number 2 of DSBDL. The problem statement is design a distributed application using MapReduce which processes a log file of a system, list out the users who have logged for maximum period on the system, use simple log file from the internet and process it using pseudo distribution mode on Hadoop platform. So what is expected in this assignment is you have to use one log file of a server in which we have certain information present in it. So we have to extract the IP from the file and we have to count the occurrence of IP from that file and we have to reduce it as the output of IP, its frequency. So this is what expected is. So for this we will write a Java application in which we will write a MapReduce or we will perform a MapReduce operation and we will try to analyze the log file which is being inputted to our program and will generate the outcome as IP and its frequency, right? So we'll start with our code. So as you all know, we have to start with the virtual machine. Once the virtual machine is started, you have to start with the cloud era. So once the cloud era is started, then you have to go to the places. Probably on your desktop, the Eclipse may be present. So we'll just start with the Eclipse. So once the Eclipse is started, you can see an environment like this. So the first step is to create a project. So we'll create a Java project first of all. So click on File, New and click on Java project. So I'm giving my project name as, I'll give project name as word count. Okay, we'll give the name as IP process. Okay, so my project name is IP process. So I'll just click on finish. Now my IP process project is created. So once your project is created, you close other irrelevant project by clicking on close unrelated project. Now my current project is IP process under which I will create a package. So again I'm right clicking on that and I'm just going to the new and I'm clicking on package. So for understanding purpose, I'm clicking the name of my project, package and the class file name same. So IP process I'm clicking. So here my I and both P are capital. Click on finish. Once the package is created, then we will create a class file. So again follow the same process. Click on class and I'm giving my class name as IP process. Okay. Now include the main function. So my source folder, project name, package name and the class file name is same. And I included the main function in my IP process class and I'm clicking on finish. So now once our class file is created, my .java program is created. Now what we'll do is we'll type a code over here. So already I have a code, so I'll just copy this code and I'll just explain this code line by line how it is working. So I have pasted the code. So my package name is what? IP process. So is it same? Yes. Now the next thing is, in Java, as you all know, whenever I want to write any code, we have to write our code inside a class. So here you can see this public class word count is my driver class in which I have written the logic for my MapReduce operation. So as you can see, the name of my source file is what? IP process. So our driver class name should be same as your source file name. So we'll change this to IP process. Okay. So now my name is same. So my error is just here. Earlier the error was there. Now error is not there. One more thing you have to see is we'll go to the main and inside this you have to change this name word count to IP process. I'll explain you what it is exactly, why are we changing this after some time. Next is, as you can see here so many errors are there because of this library which we are trying to import are not present in a current environment. So we need to link this external libraries in our current Eclipse environment. So for that the steps are right click on the project, go to the build path, click on add external archives. After clicking on this, you can see a file system in your PC or desktop. So there you can see a second last folder USR. So you have to click on USR. Inside USR you have a lib folder. Click on lib, and then inside that we have a Hadoop folder. So click on this. After path you can see USR, lib and Hadoop. So inside this Hadoop we have to link a library named as Hadoop Common 2.6.4 CDH 5.4.2 jar. So just click on OK. So now we can see here Apache.Hadoop. Earlier these errors were there. Now my library is linked, so these errors are gone. Now next we have to link similar way Hadoop.MapReduce. So for that we have to follow the same process. Click on IP process, go to the breadpath, go to the add external archive, USR lib. Inside lib we have a Hadoop -0.20 MapReduce. So click on this. Inside this we have Hadoop core 2.6.0 MR1 CDH 5.4.2.jar. This library we have to include. So click on OK. So now these errors are also gone. Now let's just check, is there any error? No. Now my program is error free. Now the next process is we have to create a jar object, because in Hadoop you cannot directly run a class file. Because in Java usually when I want to execute any Java program, we have to create a class of that, and that class file we can run for executing our program. But in Hadoop we have to create a jar file of our class. So for that the process is right click on this, go to the export, then you can see this. So click on Java. In Java click on jar, click on next, and here we have to click on browse, and you can change the name of your jar file. Whatever you feel you can give. So here I am giving the same name. It's not mandatory to give the same name, but for just to remembering I am giving the same name, IP process.jar. Click on OK. So you can see the path right now for the jar file is home cloud era, in which I have saved my jar file. So click on next, next and finish. So my jar file is created now. So click on OK. So your jar file is created, right? So now next is to execute your program. So I'll explain you first of all how to execute, then I'll explain you the line by line code which I have written or mentioned in my IP process.java file. Okay. So the next thing is to, now as you all know, this problem statement states that we have to process a log file. So first of all we'll see how or what that log file is, and what are the different content of that log file is. Okay. So my file is saved on desktop. This is the file which you want to process. So this is the file of server which is having the information, that is, this is the IP which has accessed that server on this timestamp, and some amount of information, either it is downloaded or uploaded from this link, right? So now I am interested in what my program should extract this IP from this log file. It has to count the frequency of each IP which is present in this log file, and it has to generate the output as, say, for example, 10.216.113.172 has come, say for example 100 times. So it has to generate the outcome as IP, 100. Similarly, 30.199,50. So this will show the frequency of each IP which is occurring in this file. So we will input this file to our program, and the program will generate the output which will be stored in a file named as part-r-5.0, where I can see the IP and its frequency. So we'll start with the process of execution of this program. So for that we have to click on terminal. So this is the terminal black screen. So here if I see the present working directory, for that the command is pwd. So here you can see the present working directory is home cloud era. And where my log file is present is, my log file is present on the desktop. So for that, if I want to check the content of that, I will type ls. So you can see here on desktop, okay. So on my desktop, so desktop is a folder under which my file is present. So I need to copy it from desktop to my present working directory, that is home cloud era. So for that the command is put. So we are executing a Hadoop shell command. So for that, Hadoop fs is the hyphen to start with any command. So this is the prefix we have to use. Then hyphen put, and then my file is in what? Desktop. File name is what? File name is access log file, right? I have to copy it what? In a present working directory. So I'm giving name of my file is input log.txt. So this is my file name which I want to copy, input log.txt. Press enter. So if this command is successful, it will copy your content from desktop to your present working directory. So now I want to check whether my file has come to my present working directory or not. For that the command is Hadoop fs-ls. So just check now your input log file has come or not. So now you can see my input log.txt is there. Now my file is ready, input file is ready, my program jar is ready. Now we will execute our program on a terminal. So for that the command is Hadoop jar is the command to execute your jar file. What is my jar file name is IP process.jar. Next is you have to provide a class name in which your driver code is present. That is where my code resides of mapper, reducer and driver. That we have to mention. So for that we have created a package. So IP process dot IP process. This is my path of my class file in which my code is present. After that we have to give a input file which we want to process. So this is my argument of 0. So input log.txt, and we have to give the output path where my program will be stored. So I am giving the directory name as op16. Okay, this is my output directory name. Now this is the command to execute your jar file. Hadoop jar is the command to execute the jar. What is the jar file name is IP process.jar. This is the name of my class file in which my driver code is present. This is the argument of 0 because we are executing this code from command line. So this is my input file name which I am passing as argument of 0. And this is my output directory which I am passing as argument of 1. Now press the enter. So now your Hadoop process has started, where you can see the summary of how many splits been done. So right now our file is very small, it is less than 128 MB. So only one split will be created. So on this split, the one mapper and one reducer will work because ultimately our output is only one, that is IP comma its frequency will be stored in one file. So one output and only one split, that's why one mapper. So you can see here currently my map is 0%, reduce is 0%. Now as only one split we have, so directly your map 100% will come. So your map 100% has come, and now the process has started with the reduce. So once the reduce 100% is completed, we can see the summary, how many bytes been read, how many bytes been reduced. So we'll get a summary of that, and once the summary we will get, then we'll check the output. So now our process is completed. So bytes written as some bytes has been returned in my output file. So we'll check those bytes, what has been returned. So for that the command is Hadoop fs-cat. Cat is the command to check the content of file. So my content are in directory 60. So by default the file is created as path-r-510. This is the by default file created in every directory, whichever you will give it as the output path. Okay. So press enter. So after pressing enter, you can see the outcome as just a moment. What file name we have given as op60, it's not directory 60, so my mistake. I'll give here op60 as my output path, and path-r-510 will press enter. So now you can see the output as IP and its frequency. So in my log file, I have this IP occurring 7 times, 142 is occurring 14 times. Similarly, these are the set of IP which with the frequency of that as key comma value. So manually we have to check now which IP has occurred maximum times. So as a result of or outcome of this assignment, I can see 10.182.30.199 has come 63 times, which is the maximum count present in this path-r I type 0 output 5. So this is the output, this is the program how we execute. Now we'll go to the code and we'll understand how to write a logic for this operation of MapReduce, which is generating the outcome as IP, frequency. So now we'll go to the code. So these are the set of libraries which we have to import. So as you all know, we have to use Hadoop and Hadoop MapReduce. For that we have to import org.apache.hadoop and some libraries for performing different MapReduce operations. So next is we are writing a class IP process, which is my driver class, in which you are writing a main function, right? So either you can write or you can create three different classes. One class is a driver class, another class will be a mapper class, and third class will be a driver class, which is having the logic of your mapper and reducer. And driver class will actually drive the mapper and reducer, which will generate, in which we have a main function, and we will create inside a job inside that, and we will call instance of mapper and reducer inside that. But right now, the code which I am referring is in which I have created only one class file, right? And inside this IP process driver class, I have written two classes, tokenizer mapper, and one more class I have written as some reducer class. Done. So now we'll start with the line 1. So IP process is the driver class, which is public class. Inside this we are writing one more class, tokenized mapper class. So we made this class as static because we are not creating an object of any class. We'll be directly using the class instance to invoke different methods which all are written inside the class. So we have made this tokenizer mapper class, which is doing a mapping operation on my input. Okay. So now next is what this class is doing is basically whenever I want to perform a mapping operation, we basically take the input as what your log file. Okay. And so we will take the first line as an input to the mapper, and this input will go to your mapper, and mapper will generate the output as what? Key comma value pair. Key comma value pair, right? So for this we have to tell the mapper what will be the input for the mapper and what will be the output of mapper, right? So if you can see here, this tokenizer mapper is extending a mapper. So here what we are doing is we are trying to, as you know the concept of inheritance, so whenever we extend any class, inherit any class, so we use a keyword extend. So your tokenizer mapper is extending an inbuilt mapper class, for which we are providing 4 parameters. So the first 2 parameters are the input to the mapper, and last 2 parameters are the output of the mapper. So here we are trying to make this parameter as a generic parameter. So what object stands for? Object stands for the entire line which we are passing it to our. So here your input file is a IP log file is an input to your program. That's why the first parameter is the object. Next is text. So from this input file, I am interested in what? The first line. So the first line is what? A text. That's why the second parameter is text. Once this entire file and the first line, after that the second line. So the set of lines we are are the set of strings which we are taking it as an input in my program, and this will be processed through the mapper, and it is giving me output as key comma value pair, where the output will be what? IP comma 1. IP comma 1, right? So that's why the output is what? Text comma int writable. So now what int writable is? So int writable is a Hadoop box class, right? So what do we mean by Hadoop box class? So when we talk about the data type, primitive data type are what? Integer, character, float. So whenever I want to use an int in Java, we have to use a Java wrapper classes for that. So for int, we have a Java wrapper class as integer, and for that integer wrapper class, we have to use a Hadoop box class with Hadoop MapReduce programming, that is int writable. That's why we are writing the int writable. So whenever I will pass my file to my mapper, the output will be generated as what? IP comma its frequency, that is 1. So my 1 is what? The integer, and my IP will be what? Which will be a something 192.150, say 134 dot something will be the IP. So this will be what? This is my string. This is my string. So for string, you have to understand this process, we have one diagram which I'll explain you. So this is the diagram. You can see, for example, I have a log file.txt, in which I have some set of statements, which I want to process. Every word has occurred how many times. So hi has occurred how many times, how has occurred how many times, R has occurred how many times. This I have to count. So assuming that this file size is 392 MB. So now, as we all know, the input split is what? A block size of 128 MB. So how many splits will be there? 4 splits will be there. So this is a diagrammatic representation. This is my input file. So the size of that is 392 MB. So 4 input splits will be there. For every input split, there will be a parallel separate mapper is executing. So my first input split, one mapper is working. For second input split, second mapper is working, and so on and so forth. So here, what basically happens is, when I'm passing my first block to my mapper, there is an intermediate steps coming between is record reader. So what record reader does is, record reader reads your first block, first statement from your file.txt. So how it reads is, for that we need that line is starting on which byte offset or on which byte, and next line is starting on which byte. So every line is starting on which byte, that we should know as an address to scan that line or to read that line. So record reader does is what? It will read the entire block and it will convert your output into key comma value pair, because for mapper we need an input in the format of key comma value pair, and output is also generated in the format of key comma value pair. So I cannot directly feed my input straight to my mapper. So for that we use a record reader. So record reader will do what? It will read your first line, hi, how are you, which is starting on which byte? 0th byte, right? Next byte is starting on which byte? So we can character is of 1 byte. So if I count this number of characters, these are 15 characters. So next line is starting on the 16th byte. So the key comma value pair will be generated as 0 comma hi, how are you. This is like key and this is value, comma again 16 comma how is your job. So this is how the record reader is generating your output, which will be fed to your mapper, and the mapper will process this key comma value pair, which is nothing but my object comma text, right? Because this entire line is what? Hi, how are you? So if we go to the code, in this you can see object comma text. So this object is what? My bytecode, and text is what? Your entire line. Hi, how are you? And then the output will be what? Hi, comma 1. So that is why we are passing this 4 parameter to our differential. Now I hope it is clear. So now we'll go back to this. So once my mapper has processed that input, it will generate the output as key comma value. Right? Now next is, we'll go back to the code now. So now this is how they have started. So now, as you know, the mapper always writes the key as 1. That's why we are creating a variable 1, which always holds the value as 1. And text is what? The value which we read. So here we are interested in IP. So the IP will be stored as a content of my word. So here my string is what? A word. So in Hadoop box class for string is what? A text. Right? Now we are writing one function map, in which we will pass a byte offset comma the string, that is my IP, and we will be generating a key comma value there, which will be written as a context. So context is a inbuilt of class for which we are creating the object context inside this, which is throwing some exception in case if any error comes. So what is the logic behind writing this map function is? So what are we doing is, this value dot to string split function is for what? If you observe the log file, in log file the IP is still what? Until unless the space is not coming. So after this space we are not interested in this further information, right? So we'll just extract this IP. So for that the logic should be what? The logic should be, we are using a split function. So what it will do is, it will read your first string. From that string we are interested in what? In space. So we are splitting our string until unless space is not coming. So we are reading that string and we are storing that in this token. And from that token, so we get a string token which consists of different tokens. This is my first token, token of 0. This is my token of 1, token of 2, and so on. So I'm interested in what? In only token of 0, right? For that, the second line is token of 0 we are storing in IP address. So whenever the mapper is writing key comma value there, they are setting the function as word dot set, which will write your context as IP address comma 1. So this word will be set as your IP address, and that context dot write will be written as your key comma value set. So this is how your mapper is working. Once the mapper has generated your output, then we have to give it to our reducer, right? So how your reducer is working, so if we go to the diagram again, so now here my output is generated from the mapper. Now this output of mapper will be given to what? A reducer. So reducer will do what? Reducer will use a record writer, which will again take the input as what? Input as key comma value pair, and output is again what? A key comma value pair. So what my output will be? IP and its reduced frequency. Means whenever I find the similar IPs, those IPs will be added and its frequency will be returned as the output of my record writer. Right? So now we'll go to our reducer function. So you can see again we made some reducer class. We have written a reducer class which we made it as a static. So no need to create an object in which we are again passing 4 parameters. So first 2 parameters are input for my reducer class. Second 2 parameters are the output for my reducer class. So first 2 parameters are key comma value there. But my key is what? IP. Value is what? 1. Again, output is key comma value there, where text is IP, and in fact there is a reduced value of my IP frequency. So again the same, we are creating a variable of type int. So here the Hadoop box class is writable. So we are writing a reduce function in which we are running the loop. For the similar values, we are just adding its value, that is IP comma its value, we are adding it all together, and that result for the similar IP we are writing it again in a context dot write, which is my record writer key comma result. So this is how your reducer function is working. Now we'll go to the main function. So to run this smart reducer, basically we need a main function, because whenever we run any Java program, the JVM looks for what? Main. So your JVM looks for main. So in this main function, we have to start first of all, we have to set some configuration, because of which we are able to run our tokenizer class and reducer class. What this is? So inside the main, we are creating a configuration for the Hadoop environment. So the first 2 lines are we are creating a job inside the Hadoop. Next is, as I said, we cannot directly run a class file. We have to create a jar of that. So for which class file I am creating the jar, that we have to pass over here. So job.set jar by class. So this statement will, so while executing our program on terminal, if you remember, we have executed a command as jar and our jar type, right? So this jar is basically will search for a main function. So where my main function is? My main function is in IP process.class, right? So that part we have to pass. Now where my mapper logic is written is, my mapper's logic is written in tokenizer mapper.class. See, tokenizer mapper.class. So that we have to pass the job dot set mapper class. Means my mapping will call which class? Set tokenizer mapper. Reducer will call which class is in some reducer. So combiner and reducer is always lies on the reducer side. Next is, you have to mention in your main function, that is whenever you are creating any key comma value there my key is of which type and my value will be of which type. So your IP will be always of type string, that's the text dot class, because the Hadoop box class for string is text, and the value will be in the form of integer, that's why int writable class. And the last 2 statements are, as we are executing our code on a command line, so you have to mention your input will come from which argument and output will be stored in which argument. So args0 is my input and args1 is my output. So that's why file input format dot r input path. So from where my input will be passed. So here this is the command where this is my args of 0 and this is my args of 1. So this is my input and this is my output. So for that we are writing these 2 statements. And until this our program is not completed, we'll keep on executing this code. So this is a Java program to execute your MapReduce operation for a given log file. This should give you outcome as your RP comma frequency. So I'll show you output once again. So this should be the output for your file. So we'll stop here.